Welcome to the channel Simple Concepts by DJ. Today we are going to solve a numerical problem. This is the question of the problem. It has been written as the heat element of an electric kettle has a constant resistance of 100 ohms. Okay, the applied voltage is 250 volts. Calculate the time taken to raise the temperature of 1 liter of water from 15 degrees Celsius to 90 degrees Celsius such that 85% of the power input to the kettle is used. And water equivalent of kettle is given as 100 grams, 100 G. Find how long will it take to raise a second liter of water through the same temperature range immediately after the first. So these are the parameters that is given in the question. Say they are telling about an electric kettle which is having a resistance of 100 ohms, and that kettle is operating at a operating voltage of 250 volts. So they are asking us to find the time taken to raise the temperature of 1 liter. They have 1 liter of water. They have 1 liter of water and they are asking us to calculate the time. Okay, time taken for the rise in temperature. For the rise in temperature from 15 degrees Celsius to 90 degrees Celsius. They have given the initial temperature, they have given the final temperature. So that is theta 1 is 15 degrees Celsius and theta 2 is 90 degrees Celsius. Such that 85% of the power input to the kettle is used. Actually, the power input means the heat energy. The heat energy which they are supplying is up to 85% of the heat energy that has been supplied to this system is being utilized. Okay, so the remaining 15% only is taken as, or it has been expelled as heat loss. Okay, and water equivalent of the kettle, they are giving the water equivalent as 100 grams. They are asking us to find how long will it take. They are asking how long will it take means the time duration. Okay, for the second liter of water. So they are taking the first liter. The first consignment is 1 liter of water. After the consignment of 1 liter water, they are pouring another 1 liter of water, the second consignment, into the kettle, and they are telling that how long will it take to raise the second liter of water through the same temperature. Okay, so with whatever temperature they have, they are asking us to find the temperature rise for the second consignment of water, which is 1 liter. Okay, so now what we can do is, we know that we have a resistance over here, we have the voltage over here. So since we have a resistance and have a voltage, what we can do, we can find the current by Ohm's law. Okay, this is what. So the first step what I'm going to do is, see, this heat taken by the water. So heat is taken by the water. So how to calculate the heat taken by the water? Heat taken by the water is nothing but, you know this formula, that is Q equal to M into Cp into T2 minus T1. Okay, T2 minus T1. Here M is the mass of the liquid or the substance which we are taking. Cp is the constant pressure, specific heat at constant pressure, and T2 is the final temperature, and T1 is the initial temperature. Q is nothing but the heat energy. Okay, so here what is mass? See, the mass they had given as 1 liter of water. So it is given in 1 liter. So we know that for this, we know that 1 gram is equal to 1 ml. Okay, so 1000 grams will be equal to 1000 ml. So 1000 grams is nothing but 1 kilogram. 1000 ml is nothing but 1 liter, right? So it is 1 liter. So we have 1 kilogram is equal to 1 liter, right? So 1 kilogram is equal to 1. So instead of 1 liter, I can substitute as 1 kilogram. So this is equal to, mass will be equal to 1 kilogram. Of 1 kilogram, what I can do is I can convert it into 1000 grams. I use it at 1000 grams. So the unit is grams. Grams is the unit. See, 1000 grams is the unit here, into what is Cp? Cp is the specific heat at constant pressure. So we know that the specific heat at constant pressure is 1 calorie. 1 calorie will be equal to 4.18 joules, which is approximated to 4.20 4.20 joules. Okay, so this Cp I can take it as 4.20. So Cp will be 4.20. Okay, 4.20. So this will be joules, right? And this temperature is nothing but 90 minus 15. So that will be into 90 minus 15. What is 90 minus 15? It is 75. 75 degrees Celsius. So this is the equation. So 1 calorie, we know that it is 4.18 joules, right? So so see, Cp is, what I can do is to find the unit of Cp. What I can do is Cp. If you want to find the unit of specific heat capacity, here from this equation, Cp will be equal to Q divided by M into T2 minus T1 is nothing but the difference in temperature. Difference in temperature can be denoted as delta T. So M into delta T, right? So what is the value? What is the unit for Q? Q is joules, divided by, what is the unit of mass? Mass is grams. What is the unit of delta T? Difference in temperature in degree Celsius. So it will be degree Celsius. Okay. So I'm going to substitute this unit here. Joules per gram into degree Celsius. So I'll be getting, now I'll be getting joules here, gram and gram will cancel, degree Celsius will cancel. So I'll be left out with joules. Joules. So what is the value of this joules is 4.20. 4.20 into 1000. 4.20 into 1000 into 75 into 75. So it will be 315,000. So it will be 315,000. This much of joules has been taken by the water. So what I can do is, with this one, I know that 1 calorie equal to 4.20 joules. So 1 calorie is equal to 4.20 joules. So what I can do is 315,000. 3,15,000. Okay, 3,15,000 joules. Joules will be 3,15,000 joules will be how much calories? So that will be 3,15,000 or 315,000 into 1 divided by 4.20. If I put, means I'll be getting the value in calories. I'll be getting the value in calories. So that is nothing but 315 divided by 4.20. 4.20. So if I do it, I'll be getting 75,000 calories. 75,000 calories. I'll be getting 75,000 calories. So now I'm interested to convert this calorie into kilocalories. So what I'm going to do is 75,000 calories, when it is converted into kilocalories, will be 75,000 divided by 1000. So that is nothing but, if I divide by 1000, it will be 75 kilocalories. It will be 75 kilocalories. So that is the value for this one. So that will be the value for this one, right? So 315,000 joules is nothing but 75 kilocalories, right? So now what I'm going to do is heat. This is the value for heat taken by water. Now I'm going to find what is the heat taken by the kettle. Okay, so heat taken by the kettle. Heat taken by the kettle. Taken by the kettle. Heat taken by the kettle. Let us assume that this is Q water. You can keep it as just, instead of keeping as Q, you can make it as Q water. Okay, Q water. That is nothing but the heat taken by water. So we'll assume it. We'll represent it by Q water. So heat taken by kettle. Let us assume it as Q kettle. Q kettle. Okay, this is Q kettle. Q kettle is nothing but the same m into Cp into T2 minus T1, the same thing. But here, this is for water they had given as 1 liter. So we have substituted mass of water, that is 1000 grams. Okay, but here for this kettle, heat taken by the kettle, what you need to do is they had given the water equivalent of the kettle they had given. So water equivalent of kettle is 100 grams. So instead of this 1000, you need to substitute, when it comes to kettle, you need to substitute 100. So that will become, for mass, you need to substitute 100 grams. That is 100 into Cp. Cp value will be same. Okay, Cp is 4.20. 4.20. The unit is joule per gram degree Celsius into the difference in temperature. The same difference in temperature, that is 90 minus 15. 90 minus 15 is 75. Okay, 75. So now what I'm going to do is I'm going to multiply this 75 into 4.20 into 100 will be 31,500. So this will be 31,500. 31,500. The same 100, this 100 unit is gram. This one is joule per gram degree Celsius, and this one is expressed in degree Celsius. So everything will cancel. So you'll be getting it in the value in joules. Joules, joules. Right? So 31,500 joules. Now I'm interested to convert this joules into kilocalories, like the one which I used before. So what I'm going to do is, I know that 1 calorie is equal to 4.20 joules. Okay, this is a standard notation. So 31,500 joules. Okay, equal to how many calories? So 31,500 divided by 4.20. If I divide by 4.20, I'll be left out with 7,500 joules. 7,500 joules. Okay, this is the answer I'm getting, 7,500 joules. So what I'm going to do, I'm going to convert this 7,500 joule, 7,500 calories. Okay, I'll be getting 7,500 calories. Now I'm going to convert this 7,500 calories into kilocalories. So if I convert into the kilocalorie, the higher unit, I need to divide by 1000. So 7,500 divided by 1000 will be 7.5. Okay, 7.5 kilocalories. Okay, this is the value I'll be getting. So this heat taken by the kettle, that is Q kettle, value will be 7.5 kilocalories. Okay, so this is the value. This will be the value. Okay, so I have got heat taken by the water and heat taken by the kettle. So the water and the kettle put together will be a total complete system. Okay, so heat taken by the total system. So heat taken by the total system, let it be heat total. So what will be heat total? Heat total will be addition of sum of heat taken by water and heat taken by the kettle. So that will be 75 kilocalories plus 7.5 kilocalories, which is 7.75 plus 7.5 kilocalories. So which is equal to 75 plus 7.5 plus 75 will be 82.5. Is 82.5 kilocalories. Okay, this is the total value. This is the total value, total heat that is being taken by the system. Okay, this is called as the 82.5 kilocalories. Now this is an electric kettle. Okay, so for this electric kettle we need to apply Joules law of electric heating. Okay, so what does this Joules law of electric heating states that, see, work done. Okay, so when a current is passed through a resistor, what will happen? A heat will be produced, right? So in order to maintain the current, we need to do an extra work, extra input of work should be done. So that work done is expressed as I squared into RT joules. I squared into RT joules. Okay, this is the work done. So what is heat produced? Heat produced, I'm denoting it by H. Heat produced, H. H is expressed as the ratio between work done and the mechanical equivalent of heat. Mechanical equivalent of heat. Okay, so this is called as the heat produced. Heat produced. This is the heat produced in Joules law of electric heating. Okay, so what is this mechanical equivalent of heat? Mechanical equivalent of heat is, see, we know that 1 calorie is equal to 4.20 joules. Okay, 4 so mechanical equivalent of heat is being expressed by the letter capital J. So capital J will be nothing but, this will be 4 joules per calorie, that is 4.20. The value of this mechanical heat is 4.20 joules per calories. Okay, this is the value I'll be getting. So what I'm going to do is, I'm going to convert this calorie to kilocalories. If I can do it, what I have to do is, which is equal to 4.20 joules divided by calorie. When it is converted to kilocalorie, it will be 1 divided by 1000. Okay, 1 divided by 1000 joules per kilocalories. My unit will get automatically changed. Calories will be converted into kilocalories. So this will be 4.20 into 1000. Okay, so if I multiply, what will happen? 4.20, that is 4.20 into 1000. 4.20 into 1000 will be 4200. 4200 joules per kilocalories. Joules per kilocalories. Okay, so this is the value I'll be getting. That is nothing but the mechanical equivalent of J value is this 4200 joules per kilocalories. So what will be the heat produced? So the heat produced, that is, heat is the electrical heat produced. Okay, the electric, since this is a electric kettle, we need to consider the heat produced through electric means. So H is equal to, what is work done? Work done is I squared RT, I squared into R into T. This is expressed in joules. Okay, divided by this mechanical equivalent of heat is nothing but J, that is 4200. 4200 unit is joules per kilocalories. Joules per kilocalories. Right. So now what I'm going to do, joules divided by 1 into this. If I simplify this, the unit joules will get cancelled. Joule by 1, this one, if it goes to the numerator, it will be kilocalories divided by joules. So joules and joules will get cancelled, so you'll be left out with kilocalories. So the unit will be kilocalories. For this one, it will be kilocalories. Okay, so this is the value of H, that is the heat produced. Heat produced by electrical means. Okay, so what are we going to do is, first thing is, this is the formula. Okay, so heat produced by electrical means. Heat produced by electrical means. So I'm denoting it as heat electric. Heat electric is equal to I squared RT divided by 4200. So here the value, this I is given. I is current. So they haven't given the value of current here. But we know that from this we have left out with 100 ohms and 250 volt as the operating voltage. So with voltage and resistor value, we can find I through Ohm's law. I equal to, what is I? I will be equal to V divided by R. So V, the operating voltage is 250 volts. That is 250 divided by, the value of resistance is 100. So 100. So 250 divided by 100. So 250 divided by 100 will be 2.5 amperes. So 2.5 ampere I got. So now I'm going to substitute in this equation. So it will be I squared. So this is I squared. So I squared is 2.5 into 2.5 into R. R is 100 into 100 into T. We don't know the value of T. So just leave it as this. Divided by 4200. Divided by 4200. Okay, so this is what is called as the heat produced by electric means. This is the heat produced by electric means. So now what they are asking is the heat produced, that is said that 85% of the power input. What is power? Usually denotes electricity, right? The power input is nothing but 85% of the power input has been effectively utilized. So effectively utilized means what? 85% denotes the efficiency of the kettle. So the efficiency of the kettle is up to 85%. So what are we going to do is we need to multiply this heat, that is called as the total heat that is being utilized along with the efficiency. So what we need to do is total heat with the efficiency means into 85 percentage. 85 percentage of this heat energy produced. 85 percentage of heat energy produced is being utilized effectively. So heat energy produced by electric means is this. 85 percentage means 85 divided by 100. So 85 divided by 100 is nothing but 0.85. So I am multiplying it with 0.85. Okay, I'm multiplying it with 0.85. This heat, electric heat, we have this total here. This is the total heat energy that is being produced by electrical means. And this is something that heat energy which we have derived by taking into account this Q water and Q kettle. So both are total heat energy. So this is a total heat energy. This is also total heat energy by electric means. So what we're going to do is we need to equate it. Okay, we need to equate it. So if I equate it, see here also so I'm going to equate this with 82.5. Okay, so if I, this is a total heat, this total heat, I'm going to equate it now. So it will be 82.5. So if I do like this, from this I can get the value of T here. So the value of T is nothing but T will be 4200 into 82.5 into 82.5 divided by 2.5 whole squared into 100. 2.5 whole squared into 100. So T is nothing but 4200 into 82.5 divided by 2.5 whole squared into 100 into 0.85, 0.85. So if I do it, the time period will be 4200 into 82.5 equal to divided by 2.5 divided by 2.5 divided by 100 divided by 0.85. So the value will be 652.23. So it will be 652.23. Since this is a time, the unit will be in seconds. Okay, so if I want to convert it into minutes, what I'm going to do is I need to divide by 60. Okay, 652. So 652.23 divided by 60 will work out to be 10 minute 87. So it will be 10 minutes, 10.87, that is 10 minutes 87 seconds. I'm getting 10 minutes and 87 seconds here. So this is the first part. First part is over. So now they are asking, find how long will it take to raise a second liter of water. So now they are using the consignment, second consignment of another 1 liter water. Second consignment is another 1 liter water. That is to find how long will it take to raise a second liter of water to the same temperature range immediately after the first. So now the kettle is being boiled. The first consignment of 1 liter water is boiled now. Okay, so now what, that is till 90 degree it has been boiled. Now what they are doing is they are replacing the 1 liter of water and again they are putting another fresh consignment of 1 liter water into the kettle. So what will happen? Now the kettle will be hot. The kettle will be hot, but the second consignment of 1 liter water which enters into the kettle will not be up to the temperature of the kettle. So what you need to do is now for that what you do is you need to take this heat electric that should be compared with this one. Which one? Means the heat taken. Now they are asking us to find the temperature of the water, not the temperature heat taken by the kettle. So you need to equate it with the heat taken by the water. Okay, because the kettle is already hot. So now what you're going to do is for the second consignment, find how long will it take. For that what you need to do is you need to take this one. So you need to take this part, this heat electric need to be compared with this 75 kilocalories. So that is the second part. The second part is I'll write it over here. The second part is heat electric. Find how long will it take to raise a second liter of water. So heat electric, that is 2.5. This will be 2.5 whole square, 2.5 whole square into 100 into T, 100 into T divided by 4200, 200 into 0.85, 0.85. Let us assume that this is a T1, this is a T2, okay, into 0.85 divided by 4200, which is equal to this 75 kilocalories. You need to equate with 75 kilocalories. So T2 will be 75 into 4200 divided by 2.5 whole square into 100 into 0.85. So that will be nothing but 75 into 4200 divided by 75 into 4200 equal to divided by 2.5 divided by 2.5 divided by 100 divided by 0.85 divided by 0.85. So that is nothing but 592.94. So it works out to 592.94 seconds. 592.94 seconds T2. So we need to convert this seconds into minutes. So 592 5.94 divided by 60. If I divide it by 60, I'll be getting the value in minutes. So T2 equal to that is 9.88, which is nothing but 9 minutes 8 seconds 88 seconds. 9 minutes 88 seconds. 88 seconds. Okay. So this is the final answer. So the value is, find how long will it take to raise a second liter of water through the same temperature range immediately after replacing the first. So it takes 9 minutes 88 seconds to raise the second liter of water through the same temperature range immediately after the first. So this is the answer for this problem, right? Thank you all for watching this video. I hope this video will be very helpful. Please do subscribe to my channel. Thank you.